Hello, hello. Great. Hello, hello. Um, I don't think anyone's actually here yet, but for VOD purposes, um, it's been a little bit, but I've mainly been putting off working and trying to fix this problem that after last time I didn't really want to think about, but it's got to get solved today because it's kind of blocking me from doing anything else right now. So, first off, since last time, I have done a little bit of work on my own. I don't remember why I said this. Oh, this is old. That's why. So last time we implemented new preprocs for function name, file name, line number, and a counter that will go up every time you use it. But I just realized I said I was going to tell you what I did in between. Whatever, this is what happened last time. These new preprocs exposed a problem where trying to write these functions, and let's just compile and see where we're at actually. This is not the right thing. Yeah, so this function calls ambiguous to counter here, which I believe also happens if wait, what? For platform, what? Oh, cool. Okay. So I believe even if you just call this with just a straight integer literal, I think it also fails. So like just a 5, I think this also fails. No. Oh, we're not actually compiling anything because okay, to go back to what I was saying, the thing I did last time was there was a problem with the hash generation. So the meta hash is the thing that takes all of your... The way it works is it basically looks through your entire project here, recursively in directories as well, ignoring this gen directory. And it looks specifically for CPP files because this is where your metaprograms are. So metaprogram.cpp, and if I do metaprograms, all of your metaprograms are going to be CPP files, not these DB files. So it looks for all your CPP files, archives or puts them into a tar file, and gets the hash of that tar. So it's basically like a unique value for the current state of your metaprogram code, and it just stores that in a file. So then next time you run the build script, it can do that again and compare to see if the metaprogram has changed. So for example, if I go into here and let me just change, like, let me add spaces here. That hash will be different now. So now when I recompile, it will, instead of just running the metaprogram, it's going to notice it's different and recompile it first. There was a bug that's been in there for a while where that wasn't working properly, so I fixed that off stream. And I also renamed, and it looks like I missed part of it. I renamed this final output file, which is not even here anymore. It used to be db underscore meta underscore generated.cpp, and it would be here in your base source file. That was just, as I was getting things working, that's just where I put it and what I called it. It doesn't make any sense anymore because we're generating a lot of things, so instead I put it under this gen folder with everything else. It's this final.cpp. So now it's under here. Same exact contents, it's just final.cpp. And looks like I missed something. So what is it complaining about? Error in compiling. So did I miss? In fact, let's do this. DB final. There's final.cpp. There we go. It's for Toki. Okay, so let's do db final output name will be final.cpp. Final.cpp. Let's just take care of this real quick. db final output name. Meta generated. So I did miss this. That's fine. Meta generated. That's fine. Meta generate. So I would like to have this exist in one place because I also have I have this same thing in code gen here, like this same hard-coded name for this. So if these ever get out of whack, it's gonna fail. I would kind of like that to not all be in one place, but it's fine. I can worry about that later. Okay, so is that fixed? Oh, it needs the dot or the underscore gen in front of it. That's fine. Output name. Output name. So that's gen. Right, these all need to be gen. Final. Okay. Should be good now. Cool. Okay. So that's why it was still working. We just weren't getting the stats. So let's go ahead and fix that real quick. Fixed line count error. We can push it later, that's fine. Okay. Does MetaGen also have that problem? I don't know. I don't think so. No, because it just does its own thing. Yeah. Okay. Let's close these. And let's try this again. Okay, so the 5, is that actually working? I didn't think that worked. Is that a 0? Okay, 0 doesn't. So I think it's because it's well, actually, I don't know why this is not working. So here we're calling it with an int. What does it think we're calling it with here? Is my question. So let's see, if I do this, what are we generating? Let's go to gen here. U32. Is it that one? Yes, it must be. So we're generating, yeah, we're generating a U32 version. There needs to be a better way for me to wrangle these files. Forcoder doesn't update automatically when they change on disk, so I have to close them and reopen them. That's annoying. Okay, so if I compile with a 1, what are we getting here? Okay, so I think what's happening, when it's a 0, I think it's conflicting with this, where we have a const char star. I think is what's happening. And I can actually verify that in a second. Because this didn't change, right? This didn't change at all. So if I do this, but don't print these, which is generating that C string version. Or wait, are we still... Oh, wait, no, that C string version I think is hard-coded. No. Yeah, we shouldn't be... Where's that one even coming from? U32s. Oh, test function. Okay. Here, let's get rid of all this for now and just totally go back to basics here. Right here. Okay. So that is still ambiguous. And if we look at final here, we call print this is actually generating a lot of them. Here we're doing it with U32. Oh, I'm still parsing. That's annoying. My parser does not understand the if 0. That code is still getting parsed. So let's comment these out instead. That's goofy. There. Okay, so we no longer are ambiguous, even if it's a 0 probably, is my guess. Yeah, that's why. And the moment we have one that takes a pointer... Uh-oh. Why is that seg faulting? That's bad. We compiled. We just seg fault. Let's look into that. That shouldn't be happening. Gotta get rid of all these. Right, we need to debug not the metagen, but this. And let's start here. Okay. Let's go in here. Okay, what is our const char star? It's this, Linux main DB. Oh, is this null terminated? I don't know. Well, this thinks it is. 16. 1, 2, 3, 4, 5, 6, 7, 8, 9. Wait. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Where all the indentation at? You're probably looking at this file over here, maybe? There is indentation, just not in a way that is obvious. If I go to like here, right? This is actually a generated file that is for my metaprogramming system. Or if you're talking about this, this is VS Code not understanding this. Oh, because this is the generated code. I don't insert tabs in the generated code here. In fact, actually, I probably should. Here's my actual source file where there is indentation. These generated files aren't. That's actually a good point. Forcoder, which is the editor I use, automatically, it has like magic indentation that doesn't matter what's in the file. And until just now, I didn't even notice that that's why this was happening, so thank you for pointing that out. That's funny. Okay, so this Linux main DB, let's go in here. Oh, that's not where... Oh, we're seg faulting on the second one. Oh, of course we are. It's what I said. So this one, without this function, it does not generate a C string 1, I don't think. Print. So there's the S64 that it generated for this. And I don't think, yeah, there will not be another one. Right. As soon as I do this, it will generate one for a C string. Right here. And here I come along, passing it a 0. When I read metaprogramming, I figured it was C++ metaprogramming with templates, but this is much cooler. Thank you. Yeah, I personally don't like C++'s metaprogramming. Because I've always found it confusing. Like, I know how it works, but I feel like it bloats your code a lot, and it makes your compile times a lot worse. And I also just think it's ugly. I think it makes the code ugly. So I think it makes it ugly and hard to read. So yeah, if you're interested, if you look at the most recent video on my channel, I kind of made an overview of what my metaprogramming system looks like, if you're curious. Definitely recommend watching that video if you're curious about how this stuff works. So like right now, what I did last stream was I added these new preprocs to basically replace the equivalent macros. Because in this pseudo language I'm making, macros don't really fit in with the way I'm doing metaprogramming. So I've replaced the functionality of macros with these things I'm calling snippets, which are basically macros, only they're scoped like this, and they are parsed just like the rest of your code, and turned into a syntax tree and stuck directly into the AST. So where a macro is just like textual replacement in your code, which is handed to the compiler, I'm actually parsing this like the rest of your code and putting it into the AST. But there is certain functionality of macros that you still want, one of which is stringification. That's what I'm doing today, as soon as I figure out this bug that I've run into. So that's what's happening today. I am fixing this bug and then going to add stringification. Last stream we added these new preprocs to replace the macros for these same things. So file name obviously expands to the name of the file. Function expands to the function that you're in. Counter is like every time it hits that counter, it inserts the current value and increments it 1. So it's basically like a unique number. Line number, obviously the current line number. Yeah. So anyway, what's happening here is the moment we do this one first, we are generating a print function that takes a const char star, which is a pointer. So this thinks I'm passing it a pointer. And of course calls this function, which crashes us. And if this is a number other than 0, okay, now it's just trying to do that and failing. So it's like macros, but while properly parsing, sometimes at the location where the macro is defined. So yeah, just to give you a brief overview, this metaprogramming system, I wrote my own parser. It started out just as a C++ parser, but then I've expanded it in all these other keywords and stuff that you're seeing. So it's doing a lot more now. So the way I'm already parsing your code and making a tree out of it, I'm just doing that for snippets as well. But then the snippets I can just insert directly into the tree wherever you call them. So this chunk of snippet code here, for example, like this bits divided by 8, whatever you pass it in, this will get turned into this literal thing as if you typed it over there. It won't be like a function call. So in that sense, it's like macros. It's inserting it directly into the tree, but like you said, it's parsed and handled like normal code before that. It's not just textual replacement like a macro is. So hopefully that makes sense. So why, I figured this would work. Or no, it wouldn't. As long as this function exists, that won't work, because it's still trying to pass this as a pointer, unless I specifically cast this to like U32, and now it knows to go generate one with a U32. So, okay, that's definitely what the problem is. So the loose way I tried to solve this last time is anytime I see an integer literal, I thought I could just insert a cast before it. I can just stick it into the tree, and then everything should be fine. When I tried that, it didn't work last time, but I was also very tired and did not, I think, fully think it through. So let's just try this now. We have a very simple case here where this is not working. So let's put this back to normal. Very simple case where it's failing. Let's go into code gen. Yeah, thanks. The entire metaprogramming system I'm building is really cool. It's really powerful and neat. So like for one just quick example, you can just write, if you know what like an abstract syntax tree and like what the tree version of your program looks like, you can write these metaprograms, which after it's done parsing your code, your metaprograms are just given that whole tree, and you can do whatever you want to it. So like, for example, here's a metaprogram I wrote that loops over every struct in your program, for example, and generates two string functions for them. In this case, it's to power like my print system. So anytime I write a new struct, I never have to write a print function for it ever again. It'll just create them. And so you can see here, like for every struct in my program, I'm creating a function decal. It returns a dynamic string. It's called toString. You add parameters to it. Then we're gonna start the body of the function, loop over all the struct's members, and do our stuff. At the very end, we end the body, and we add the function decal to the program. That's all happening in this initial, if I compile. See how it says running metaprogram, and then it compiles your main program? This step is where it's doing all the metaprogramming stuff. It's parsing your code, building the AST, running your metaprograms, which modify the AST, and then spits out that giant, unindented, crazy file on the right. Yeah, so I do go over that in that video, but I can show you at any time. You can just print out the tree that gets built. And in fact, let me write it out to a file because it's huge. AST. Let me open that in Emacs really quick. So I am generating an entire... So it's not totally proper because, like, you would need a lot more information in here in order to... If I were writing a compiler, I would have to do a lot more work here. My tree is just enough that I can spit it out as C code, and then I just hand it to the C compiler. So, so it is the entire tree. It's the entire AST, but compared to like what Clang would give you if you were to ask for its AST, it's definitely simplified. But it is your whole program. The code that you're seeing over here in Final, all of this is the entire program. It's the entire thing. Not generated from your text over here. It's generated from that tree. So, and in fact, this human readable version of it, this is also all generated from that tree. So I can recreate the source code just fine from the tree. So, but it's definitely missing a bunch of stuff that you would need if you were, for example, writing your own compiler. There was definitely more stuff you would need to know. So I am definitely piggybacking off the C compiler to do the actual code gen and stuff at the very end of the day. So let's go to post pass on the parser. So we have these post passes that every time we parse code and get an AST, we run this post pass on it, which does a few things. It updates any function calls that we identified as... So by default, if you call a macro, it looks like a function call, so we call it a function call. This function, the first thing we do is we look for all those, see if they match a macro, and we change it to a macro call. Same with snippets. this is the part that replaces those call sites and injects actually the just the snippet body. So that does that part. And then we resolve all of our decal refs and type references and stuff, so everything's pointing at the right places. Dude, yeah, so they're saying parsing C++ always sounds like a bit of a mess to parse, like so many parsing rules all over the place. That is absolutely true, and I did it initially as a learning experience for myself, and I wanted to add metaprogramming to C that was a lot simpler. And once I had it working, that's when I decided to instead just add more stuff to it, and it's kind of morphed into this kind of mini new language. But yes, I don't know if you saw earlier when I casted this, I introduced this new casting syntax using this less than greater than instead of like the C style cast like this. There are too many situations in C++, and I'm sure you're aware of this, where doing C style casts is actually almost impossible to disambiguate from a function call in a lot of places. It's called like the most ambiguous parse or something, most perplexing parse or something. And it got to the point where I realized if I'm already manhandling the code gen like this with an AST, I can just rid myself of all that complexity. So I do that in a few places actually. So I'm not strictly parsing C++. If you were to point my parser at a C++ file at this point, you're not guaranteed for it to work. Yeah, so, which is why actually, if you're going to interface with external libraries, I added syntax for, where do I do this at? I added the syntax for this external keyword. So like, for example, if I'm on Linux and I need to include like Unistandard and memory management stuff, so I don't want to parse these files, especially system files like C headers and stuff, or even worse, the source code. So I eventually decided to bite the bullet and just say, I'm going to officially not have this parse C anymore. And instead, anything that you use, you just have to be explicit about it, right? So in memory management, I want to use map, mmap, and munmap, for example. I introduced this external syntax, and you can just give it the signature for the thing in a way that my code base is expecting. So like, just give it the syntax for the functions or the variables, and then it completely integrates with my metaprogramming system without having to parse this stuff. So I did kind of cheat. I did take a mulligan on just not wanting to parse that stuff. I started down that route, and it was just, this is way easier. I like being explicit about things anyway, so, but I'm technically cheating, so, but that's fine. I made my peace with that, so. So anyway, here in this post pass, I think what I want to do is at the very end, the very last thing I'll do is, let's create a new function called inject literal typecasts, I guess. It'll take the parser and the AST, and is this, yeah, so we can just put it right here. Update custom preprocs. It'll take the parser. So my eventual goal is I'm gonna be building like cross-platform libraries and stuff for like game development. That's what I ultimately want to do. But I'm having a blast with the metaprogramming stuff right now, and keep finding new ways to extend it. So, but my ultimate goal is to have a cross-platform, general-purpose like software library and game engine powered by this metaprogramming stuff. So, if you're curious where kind of the ultimate goal for this is. So update custom preprocs. So first of all, let's just let's just look over for every integer literal, and I forget why I called them. Let's just look for every literal in the whole code base. I imagine it's a bit like doing language dev, which is really, yeah, that was something that I've never had any experience in. Yeah, never had any experience in. And even just parsing seemed really complicated and crazy to me. And within the last year, I just decided to go for it. And I found it, A, wasn't that bad, really. You just kind of take it one step at a time. B, I learned a lot. And C, once I had the parser working, I suddenly realized adding my own stuff to it is trivial and super fun. So all the weird like stuff specific to my syntax has been really fun. So, and yeah, I've been trying to stream this progress more lately because as I'm having more fun and getting closer to being able to actually use it, I just decided to start streaming it more. So, and people always ask me to go over the metaprogramming stuff, which is why I made that video so I can point them to it. Which I think you can see in my Twitch about page, or about below the stream. But yeah, if you're interested in seeing kind of where this goes, I'd appreciate a follow, because I just enjoy sharing this stuff, you know, it's fun. Thank you. I kind of hate doing the call to action things, but every time I do it, it seems to work, so I appreciate that. Let's just print out what we get. Let's just print node nicely. And just verify that we can see all of them. Node and verbose, that's fine. Okay. Let's just verify we can see. Wait, what? Do I already have this? Oh, did I not remove? Oh, this is not the right name. Duh. There we go. I mean, yeah, that's fair. Okay, here are all our literal integer literals in the program. That's great. Let's print out their parent actually instead. And actually let's do print AST of node parent. Oh, this doesn't take a bool. Okay, so the one we're looking for is function call to print. So let's find print. Here we go. This is what we're looking for. So I rarely follow people on social platforms like on YouTube. I'll just look up channels and see if they posted things. Yeah. I did a pruning of all of my subscriptions like last year, just because I realized I just wasn't watching most of it. And then these days, I actually use the home page on YouTube a lot, where it just recommends you stuff. And turns out, if you've watched a couple videos of somebody, when they upload a new video, it'll show up in your home page. So I'm like, I think they call that like soft subscribing to somebody. I feel like I do that with a lot of channels these days, which is kind of funny. So I think I can just replace this with a cast instead. And I think that should just work. So when we get one of these literal integers, we will, can I get the value of it? How do I get the value? So, well, I guess I don't need the value. No, I just need to add a new node for its parent. Let me see what a cast looks like in my tree, because I don't remember. If I compile this and look at the tree and grep for print with some context. So here, right. So I want to replace that literal integer 1 with this node, which is a expression cast, And I guess we can just do S64 across the board. That's probably fine. With this as that's nice. Yeah. I've definitely found some cool channels that way, but am very dismayed at the amount of slop that shows up on all of my feeds, actually, which is why I've actually cut down the number of feeds I look at too, for that exact reason. So I think this should be easy. I should be able to just take this node, create a cast above it, and replace it with the cast. So let's do that. Let's create a copy of this node. Or wait. No, we shouldn't have to do that. We should be able to say node literal is the node, and then let's create a new one. Cast node. Create node. I forget. Do we have to? Okay, I can just make one. So AST expression cast. And what do they want? A cast wants the new type as a string. So we'll say expr cast dot new type. We'll just make them S64s for now. And we will the new type node. We don't have to give it that. That's a base type, I think. Well, let's do we need to do this? Okay. I think that's all we need. So we can say cast nodes. Or no, hold on. Do we have a replace? I think we have a replace. Replace. Yeah, replace node. So replace the node. We're going to replace the literal with the cast node. And then we're going to do we have append? Append child. We're going to append to the cast node the literal. Right? So we grab the literal, create a new cast node to cast it to S64. We replace the literal with the cast in the tree, and then append the literal to the cast. Yeah? So let's see if that works. Let's, oh, but only, only if the literal parent is not already one of these casts. Type equals AST expression cast. So if it has a parent and its parent's type is cast, then I just need to see if parent info expr cast dot new type equals S64. So if that's the case, we can just skip this one. Yeah, we can just skip it if it's already being cast to this. So this should run the same way it did before, but it didn't. Wait, C style cast, what? Wait, C style, that should not be in here at all. C style casts are not supported. It's inserting a C style cast. Excuse you? C style cast. Try parse C style cast. Where are we doing this? If next type is parent open. Oh, probably in CodeGen. We're probably append node as string. Oh, right. Right, okay. Is metaprogramming part of what gets parsed? Can you do metaprogramming on the metaprogramming? So the way it works is initially, and actually I can pull this up over here. So this is in CodeGen. if I go to postpass, run metaprogramming. Okay, run metaprograms. So what it does is it takes just your source code before any metaprograms, just the code of your program. It parses that whole thing into a tree. Then we run all of your metaprograms on that. Okay? So, what that does is spits out a bunch of new files, potentially, or new functions, or whatever. And anything that generates gets added to a queue that then we rerun the metaprogram on that queue. And if that generates more stuff, we do it again. So that primary chunk here, that primary chunk file is anything that got generated off of your base code. And then every iteration after that are these secondary chunks. So the metaprograms themselves are not getting parsed. I don't think, as it stands right now, that you can generate metaprograms with the metaprogram. Not strictly, because... Well, no, that's not true. Because you can generate metaprograms, you can't stick them... So the way it works, if I make a change to the metaprogram real quick, so it'll recompile it, because I also generate a hash based on your metaprogram, so I only recompile when I have to. Okay, so this compiling metaprogram step, that's actually where it includes all of your metaprogram CPP files. If you then generate new metaprograms, we've already compiled your metaprogram, so those can't be included. You would have to compile your metaprogram, run it, see if any new metaprograms run it on just your metaprograms, see if any new metaprogram code got generated, and recompile the metaprogram again before finally running it on your code. So yeah, there are ways to do that, but my system does not currently support that. It would require some more rejiggering, but theoretically it's possible because I'm just parsing basically C code and spitting out C code. So if the C code you're spitting out is more metaprograms, then you absolutely could. But yeah. Sometimes I say a lot of things and don't know if it makes sense. So hopefully that made sense. So why are we spitting out pen node as string? So when we see a cast, we want to spit it out as a C style cast because ultimately we're spitting out C code. But if we're generating stuff, that's why. If we're generating stuff in... Although, wait a minute. That doesn't make sense. Because it's failing in the primary chunk, isn't it? Yeah. Yeah, I don't know if you've ever followed Casey Muratori or like Handmade Hero. He's talked briefly about his metaprogramming stuff, and that actually inspired a lot of me wanting to learn this stuff. But he mentioned that someone asked him that same question. Have you ever written your metaprograms to write the metaprograms? And he said he tried it a couple times, and every time it was just, he said it was just unwieldy enough that he never followed through on it fully. So it does sound very interesting. It would be something I'd like to explore sometime for sure. But I'm only just now really getting my head around like normal metaprogramming, so I feel like I would need to be a lot more comfortable with this before I can move on to that. Okay, so I am in the what is the primary chunk? I'm spitting out C-style casts in here for some reason. Even though this... Oh, because these are CPP files. Duh. Yes, I spit out C-style casts here. So I think what's happening is we parse your code, I stick casts in there, and then if it generates code that itself needs things casted, the problem is I'm actually a little confused about why this is becoming a problem. I think it's because this sometimes spits out the final C file, but sometimes is spitting out the intermediary where we don't allow C style casts. I think, let me just verify that that's true. So if I do C style cast, so in this parser, let's do this. Let's just really quickly introduce a static here. I feel like I need to skip this check. Although wait, why are we trying to parse these anyway? We try to parse them to let you know an error if it sees one. So why would we be calling? Let's print out the chunk of code that's failing this. We're in primary chunk. Or let's step through this and figure out where this is happening. So let's go back to debugging this, the meta stuff, and not the... Oh, I already have a thing here. So when we hit this, where do we hit this? The result is a C-style cast whose children are a literal integer whose number is, it's unsigned 0. Or no, this is a, yeah, it's 0. Where are we though? So this thing's parent is, has no parent? What? Error context operation. Wait, what? Where are we? Do parse expression. We are in a return statement. Next is parent open. Parser, current lexer, we're primary chunk, right? Cursor, oh, where are we? Tokens. That's bad, I can't open that up because Visual Studio chokes on this. That's unfortunate. Okay, let's just see where we were. So result is we return a binary we're here. We're in an expression that has a return. Let's look at the metaprogram real quick. Are we doing a cast in here? I don't think so. We're not casting anything in here. What about in here? I could just be casting from a metaprogram when I'm generating code. I don't think I am though. Let's look at the print. Am I doing this here anywhere? it was also a return statement this was happening in, so it was a return statement that was a binary operator as well, which also doesn't format string. Oh, this is just verifying. That's nothing. So return build string. So we're not doing it there. Return. I don't think we're doing it here. Nope. Yeah, the editor I use is called forcoder. I just use Visual Studio for the debugger. I don't like Visual Studio's... well, I just really like this editor. I've used it for a really long time. I used to use Emacs, and now I'm using this thing called forcoder. I'm just very proficient in it, so I use it over Visual Studio's debugger. And actually, Visual Studio, for the longest time, has been the best visual debugger on Windows, so I just used it all the time. I've never found a good visual debugger on Linux, like ever. And on Windows, I've actually switched to this new one called RemedyBG. Sorry, yeah, VS Code specifically on Linux. On Windows, I use full-on Visual Studio for the longest time for debugging still. On Windows now I use RemedyBG, but then I found that VS Code with a certain plugin can get you pretty close to the debugging experience from Windows on Linux. Yeah, I mean the VS in VS Code does stand for Visual Studio, so it's very confusing. I just refer to the whole, whether it's VS Code or Visual Studio proper, I just always just say Visual Studio. But yeah, it's confusing. But yeah, VS Code with the LLDB or whatever debugger, you get pretty close to the debugging experience that I have on Windows. So I've been using that over on Linux, and it's been pretty okay. But yeah, I definitely don't edit in any of those editors. So, so we parse the expression. We parse another expression. Parse expression. So here, let's see. The left-hand side at this point is what of this expression? It's a declref. That'll help us. It's a declref value. It's a declref called value. So we have a lot of things we call value. So that doesn't help us a ton. The rest of the IDE drives me crazy, but the debugger is mostly fine. Yep. Could kind of do with a better setup, but honestly, yeah. Yeah, no, I feel you. It's kind of a nightmare. If you notice, I don't even really use like IntelliSense or any of that kind of thing anyway. The most thing I use is it'll tab autocomplete. So like I have this variable called result. If I type RE and just hit tab, like it'll autocomplete it for me, and it'll go through all of mine that it might be. I pretty much just use that, and that's about it. And I found I don't really miss it as long as I do that. I've been doing that long enough, but Visual Studio is just so bulky at this point, and something that drives me insane on normal Visual Studio, it happens, and it also happens here on Linux, is when you step, and here I'll just like do this. I'm sure you're aware of this. If I step here, like I need to do it in a earlier spot, but so like here's the string, right? If I step over this and it gets a value, see that, how it took like, I don't know, half a second to update that? If there's a bunch of things in a row and I step, that little delay wouldn't bother me very much if that's all it was, but it actually won't update this until I'm done hitting, well, okay, I'm breaking out at this point, but it won't update this watch window until I've stopped hitting it for that little delay. If I'm stepping over a bunch of code in sequence, it's not going to be updating that whole time. So yeah, I feel you. Yeah, this specific thing with the watch window is just, it's a nightmare. It's really unfortunate. And yeah, I switched over to Remedy BG, which is started out as like a community Handmade Hero-esque debugger project, and it has since kind of become a pretty proper debugger in its own right, and it comes up immediately, it's lightning fast, it does what it does really well. Unfortunately, there's no Linux version, so I'm stuck here. So the results, so it doesn't have a parent. I'm very confused about that, but when we're in parse expression here, the left hand side is a declref called value, right? Yeah, it's called value. The line number doesn't tell me anything because we're in the primary chunk. The next is a less than, though. Okay, hold on. So if next is less than, feel like a lot of stuff in Clang tends to be overall better. I'm surprised someone hasn't made a good tool yet you can find that works with Clang. So this is way off in the future, but one of the things I would like to understand more is on every platform really, but especially on Linux, is like the ELF format, you know, the dwarf debugging symbol format, all that stuff. I think it would be a very fun project to build a visual debugger on Linux, like kind of from first principles. But, and theoretically, as long as it's built properly, it would work on other OSs too. You just have to kind of abstract out the debug symbol format, like the object file format. That's a ways off for me, but one of the things I would like to do eventually once I have a working cross-platform library with all this stuff is investigate building a debugger like that. I think it'd be a good experience, and also, who knows, it might turn into... Yeah, wrote like 90% of the code for an ELF dynamic function linking code, and oh my god, it was so annoying. It does worry me a little bit. I am a total... like, I know nothing about it, really, about any of those formats. So I'd be going in pretty much with zero knowledge. So you saying those things is both intriguing and also kind of terrifying. So, so let's see. If I can get to the linker here, or the lexer, right? So we're on... oh wait, where's the parsers? Token cursor is 18. So let's do this. Let's do parser, current lexer, tokens, parser, token cursor. Okay. Also, for stream purposes, I have to make this font super huge, which also makes using this interface not super fun. Thanks. I appreciate the encouragement. I do look forward to eventually doing that kind of thing. So, okay. Parent close. So let's go backwards, actually. Let's see. Wait, that's also parent close? Oh, okay, hold on. Parent open, okay. Another parent close. Okay, this is telling us something. Here's our cast, right? So it was close, our declref, open, close, and now we're seeing S64. It's an identifier, so this is our cast, right? If we go back one more, there should be the open paren. Before this is what? Less than. Value is less than, and then we're casting something. That's where we're at right now. So we're comparing something called value, and we're casting a Ooh, it must be an absolute value. It is. Value is less than 0. Okay, that's where we're hitting. Found it. Way off in the future, I'd like to write custom linkers for my language so I can properly integrate error messages with the rest of the language rather than just seeing undeclared reference to implicit foo. Yeah, so are you working on your own language? Or is it similar to kind of what I'm doing? Or are you kind of doing something more sophisticated? Because that's something I tried to build in, even though this is just a parser, really. I tried to build in really good error messages for me, but I'm really just parsing. I am not at the stage where I have to link stuff and resolve things and do that whole stuff. So I can imagine that is exponentially more complicated. That would be really cool though, if you get there. That would be awesome. I also think it'd be fun. One of the other things I want to do, I really like forcoder, but I think I'd really like to write my own editor, especially now that I have this language kind of getting built. I would really like to build some kind of editor that understands these meta capabilities and maybe can visualize some of it and just be incorporated a little better. One of the things, like you mentioned, is since I'm parsing the code anyway, I can almost, because the parsing happens really fast. If the metagen is in release mode, it happens in like, I don't know, less than half a second. It's pretty fast to parse a bunch of code. So it'd be kind of cool if, like, just while you're editing, I'm just periodically running the parser and can kind of point stuff out while you're editing, stuff like that. It's an independent language. It's not like parsing custom C++, so though it does share conceptual concepts like destructor, constructor, move. Basically C++, most semantics are very similar. Well, that's cool. That's awesome. It's cool to hear that you stumbled into my stream doing kind of what I've been trying to work my way to doing. That's really cool. Okay, so we're in math. It's this right here. This 0 is getting casted. And this is a function template, which might be where the problem's coming in, because we spit out this. Right, okay, that's where the problem is. We're spitting out these chunk files, which are CPP files, but they aren't treated that way by the parser. These are treated as .db files. That's the problem. This final output is a CPP file, absolutely. It's being passed to the compiler. These chunk files, though, they're not, and I'm just now coming to that realization. These are not C files. So when I generate this for the next stage of the process, I can't be inserting C-style casts in here. So let's go back to CodeGen and cast. So if we are I don't love introducing another thing here, but this is important. So if we are emitting final output, we'll just say false for now. Do I forward declare this? No. Wait, I must be. Yes. Yes. Emitting final output is false. The DB files are your own thing. Also, guess you cannot start messages with dots on Twitch. That I think you're typing a command. Oh, yeah. So when I finally decided to move on from just parsing C and adding my own stuff, I just made up .db. So those are my quote unquote language, which are just my initials. And so one of the things I've done, and I go over this in that video as well, is, so you saw how you can write metaprograms to spit stuff out and you can loop over your structs and stuff. Well, I've added some of that functionality to the text itself. So like for example, there's this any keyword. You can just declare a function parameter to have type any, and based on the places you call it, based on the calling site, it will generate ones that take those types. In fact, that's specifically what I'm trying to fix right now, is when you call this, it generates one with a C string, which is a const char star, and then it will think this is also a const char star. So instead of generating a new print function, it will go try to match to the const char star version. So anyway, yeah, so I've introduced stuff like this. So you can say any. I've also added these ellipses. So this could just be a normal parameter, right? But if you do ellipses, it's basically a, in my opinion, better version of variable arguments. If you define your last parameter to be a ... it introduces a couple things into your function. You have implicitly this num any params. Yeah, kinda. It's just kind of manhandling that in the tree and generating the right tree, so it spits out the right code. It implicitly adds this num any params, which you can query to see if they even passed you anything here, right? And then I introduce this new keyword for any, which you can treat as just a for loop over those parameters, and you can access the parameter this way, right? So as long as you're in for any, you can get the parameter. You can also do this to get the type of the parameter and use it as a type. But the way I'm doing this is, behind the scenes, this for any is really unpacking the, say I passed it 3 different parameters here. What this is doing is generating not a for loop. The ultimate thing is generating is 3 scoped blocks where this is first replaced with your first parameter, the second one's replaced with your, or first replaced with the first, the next time it's replaced with the second, the last one's replaced with your third. From your perspective here, you don't have to worry about that. You just see it looks like a for loop, but the code that's generated in this final here, in fact, if I go to format string, we can go find where it generated one. Actually, let's do that in the chunk file. Format string. It's here. So you can see here. Here's one where I passed it. Wait, where am I? What was I just looking at? Format string. Why does it take a ... though? Oh, right. Okay. Yes. Sorry, I got confused. So unfortunately, I don't have here. Let me just generate one that takes multiple. So, right. So it's actually not so bad complication-wise. What did I do? Did that not work? I'm kind of now taking a detour from what I was doing, so this could be a separate... Okay, there we go. So... Oh, but we're failing, so it's not even going to recompile anyway. It's fine. Basically, it will generate... Yeah, exactly. So it will absolutely do exactly that, and you can kind of see that here. So this format string function, you can see that it is if num any params, create a new builder, and then for every parameter we're going to append stuff to the builder. You can see what it generated was if any params, create a new builder, and see how it inserted a chunk here? This is that loop. All of this stuff in between the loop expanded in a single chunk here, and anywhere where it saw param, it replaced it with ellipses arg 0. And if I had passed it more things, there would just be another whole chunk after this where it's ellipses arg 1, 2, all the way down. But what's nice is, I don't know if you have seen this ultimate file that gets generated, there's all these line directives in here. The function that gets generated here this line directive tells both the compiler and the debugger to treat this next line, the next lines of code, as if it's coming from here. So what's really nice is I can point every chunk of this unrolled loop back to your initial place here, back to this. So it'll still map one-to-one to your for loop back here, which means when you're debugging, you never have to treat this like it's anything special. You can step through this, and then it'll go back up here. You'll still be stepping through it just like a normal loop, as long as you set these line numbers properly, which I am doing in the code gen. So I thought that was kind of a cool way to handle that. So where were we? Right, so emitting final output. Let's do that. If we're emitting final output, I only want to do this cast syntax if we're emitting final output. Otherwise, I want, let's do this. Okay. If we are emitting final output, you know what? No, that just makes it gross. Okay, if we're emitting final output, we'll do that. Otherwise, we'll do this. And the only time we're emitting final output, I think what is neat is if you were to have lower access to the LLVM IR, you'd basically do the same thing, but you could do it with a basic block instead of duplicating the code per parameter. Yeah, that's one thing I've not looked at either, is the way LLVM does stuff. But you're right. If you were doing, I mean, hell, even if you were integrating this and writing your own bytecode, like if you were writing the compiler yourself, yeah, you could translate that very easily into an actual loop, which I assume that's what you're saying. You would do that in the LLVM IR layer, which means it would just spit it out as a normal loop as well. Which, yeah, it's something that unfortunately I'm piggybacking off of C here, so yeah, it is what it is. So emitting final output. So when I say pen node, okay, actually this can't be a parameter here because so many different things call this. This is going to be a little gross. It means I can get rid of this, which is nice. Pen, so I can get rid of this. I don't want this here. But, well, I guess I have I can put it on the parser. Maybe, do I want it on the parser? Yeah, the parser already has the generation queue in it, so that's probably fine. We'll say emitting final output. And here, this will be the global parser. And that means run metaprogram. Wait, where do we do this at? Generate source file for chunk. Is there a generate final? Where do we do this at? Generate source. Let's go to main. Do we do it over here? Metagen main. This is the platform independent main that kicks off the Lexing. Oh, right, okay. This is the platform file for Linux. We set up everything we have to set up, and then we just call the generic metagen main. We'll do that from every platform. So here, final source is generate source file. So once we're here, can we do this here? Let's see. Generate source file. Do we have a global parser here at this point? Okay, let's not put it on the parser. I lied. Let's be even grosser about it, but it's fine. generate source file here. We'll just say final output, and we will say if final output emitting final output global is final output, or just this. It's gross, but we're gonna do this for now. It's false. And at this point, we will say true, because at this point we are officially done. That's fine. Okay, let's just see what that does. Oops, I messed up the switch statement. What did I do? And how did I do it? This is no longer this. So if that, else that. What did I do? Oh, is it because that was wrong? Is that literally all it was? No. Break statement not within loop 2879. What did I do? How did I screw this up? I did something dumb here. Is it in here? No. What did I do? Oh god. This function is too gnarly to be making stupid mistakes like that. Let's go back and just see what I did. Okay, I put that in there. Stuck that in an if. Yeah, I'm not seeing where that happened though. That's my, let's go back here. So, because it's not in here. It's not there. That's fine. Oh wait. That's why I added. Oh, it's because I replaced this if. Okay, I was going to duplicate this if and then didn't, and I left the brace in there. Whoopsie. Okay. Primary chunk 4. Okay, well, we're getting past that part. Yes, exactly. C++ error moment of truly all time. 4. Holy moly. This is not proper output. What is it even doing here? Bro, what are you doing? Hello? Let's go see if it did this part correctly though. Okay, it didn't do this part correctly. Oh. Well, first of all, I shouldn't be casting this. That didn't actually matter. But I shouldn't have been doing that. So this is correct, right? We are seeing... That's right. If I remove this... There. That's correct, right? Print S64 of 1. That's how you would write that. But over here, we are definitely not right here. This should be value is less than S64 0. Wait, it's this. This part here, if I remove this, Or is that correct? I think. Let's see. If value is less than S64 0. Yeah, okay, so that's right. Why did we add this thing in the middle? Good question. If emitting final output, we do this. Otherwise, we do this. Do we have a... No. Well, let's step through this. We're on primary chunk line 3. So let's break on there. We are in code gen. What line is this? 2873. Okay, let's break right here. And let's say that, what are we in? Node line number is 3. Okay, we should be in the primary chunk, which we are. The node is a cast expression whose value is a literal integer whose value is 0. Yes, we're in a 0. Okay. Right, because we're here. We're emitting this code right now. We should be emitting this. That's what we should be emitting right now. And we are not. So let's figure out why, shall we? So the builder right now. Oh, come on. Builder strings 0. Wait, what do we have right now? Strings. Oh, it's a linked list, right? So, U64 something, absolute value, open paren, S64 at wait, what? Value. That's weird. I'm not sure what that's about. Return. Here we go. Return. Parentheses. Value is less than, and this should only be. Oh, why is it 2 less thans? Why are we putting 2 less thans in there? That's weird. Okay, and we end there. So by this point, by the time we get to this cast, we have already inserted something really weird into here. We've inserted less S64. Yeah, we've already inserted this weird ass whatever this thing is. Why? Where did this come from? We are in generate source file for chunk. Let's just look at the function, shall we? So this is a function who's got a parameter of type S64 called value, right? S64 called value. And it's got a compound statement that looks like a single return statement who's got a ternary operator, which is, and actually let's go to, no, actually that's fine. It's value is less than S64 0, this, and negative value or value. So this should have 3 children. The binary operator, which is the less than. Here's the negative value. It's a pre-declref. And here's just value, declref. So here's the binary operator. Should have 2 children. A binary operator and a cast. Why is there another binary operator in there? So the cast is correct. It's got a literal integer in it. That's fine. This, though, what are its 2 things? Value? What? Value in S64. Which is what we're initially... No, hold on. What is happening? This is confusing. I wonder if it's interpreting this that I'm inserting as... Let's do this. Let's print out the tree again and just go look at it. So absolute value. So here's the initial function template, right? It's a ternary operator who's got a binary operator. Its value less than S64 0. It's a cast of 0 to S64. If it is, we return negative value. Otherwise, we return value. Great. Here's the primary chunk. Here's the function we generated with that template. Yeah, look at this. We've got an erroneous binary operator in here. So we're saying greater than... yeah, so it's just getting totally lost on that expression. So when we go to parse expression, leaf, less than, if we see a less than, it's a DB style cast. Okay. Oh, okay, yeah, because this parser is not... No, that should be working just fine. Why is that not working? The tree we're generating here does not make sense to me. We're spitting out... So, I think here, wait a minute. I'm gonna actually step through this now because now I need to know what this parse expression is trying to do here. Let's get rid of these. Let's go to parse expression, which is here. And next, we're going to say next type is, no, next line is 3. Unfortunately, this is going to be, wait, what? Oh Lord, there are fireworks going off. We're in print. We are in, okay, this needs to wait until we're in. Unfortunately, I can't just check this easily. I always hate having to do this. Parser, cur lexer, file path, dot data. Let's say 0, 1, 2, 3, 4, or no, 0, 1, 2 is an underscore. Then we'll at least know we're in our generated place. There we go. Okay. We're here. So, ellipses arg 0. This is not the right place because we should be seeing return is what we should be seeing. No? Oh, we're already past the... Okay, hold on. This is not where I need to be. I need to be here. Lexer file path 2 equals this. Okay. Next is a preproc snippet. It's a curly open. It's a preproc. I need to wait till it's a return statement. Oh, was that it? Actually, that was a keyword. Oopsie, I'm not paying attention. Keyword, it's an if. Wait. This line is not 3. I told it to look for 3. Did I not? Hello? See, this is what happens when I'm using... Like, is this breakpoint just not doing what I asked it to do? This is clearly not line 3. And in fact, the file path isn't working either. That's just straight up not working. At all. Okay, cool. Let's recompile real quick. Next line equals 3. 3? 3? Okay, so that part worked. And... oh. Well, I should probably write this correctly. It's dot data. There we go. But we're still not hitting the thing. Okay, let's do this. Let's break here and say value dot data 0 is R because we want the return statement, and it's probably silently failing if you mistype it. Yes. Yep, that's definitely what was happening, and we'll say that's on me, but at the same time, it shouldn't just keep going, assuming, I don't know. Yeah. So next, I want to make sure we're in a chunk file, so lexer file path, data 2, okay. You know it should say something. Yes, it definitely should. Here we go. Line 1, which I don't think is right, but we're on the return. Question though, where did we come from? Did we come from a function? Function decal. And is this decal absolute value? It is. Okay, we're in absolute value. This is where we want to be. Great. Fantastic. Took us a while to get there, but we're here. Return. So we're going to create the return node. We expect there to be an expression afterwards, which there is. We're going to parse the expression. Okay. We are here, finally. We've made it. Next is the parent open. Left, we're going to parse the expression leaf, which in this case, well, let's just see what it is. It's a parent open. Okay, so we skip to the next one. It is another parent open. Okay, so we grabbed a parent open, we skipped past it, and grabbed the next thing. You know what I need debuggers to support? Chaining breakpoints. Oh, hey. Yeah, dude. Yes, without even like trying to mentally express what you're saying, I know exactly what you mean, and that would be incredible. That would honestly be incredible. Maybe it does exist, but I don't know about that, so that would be awesome though. Okay, so we found a parent open. We skip to the next one. This is used to be where we would just try to parse the C-style cast and put it in the tree. We don't do that anymore because we don't allow C-style casts. What we do instead, we still call the function and just see if it would have parsed to a C-style cast. If it did parse to one, we tell you, hey, you can't do that. Otherwise, we keep going. So let's just go see if we parsed a C-style cast here. And this is kind of nice. So the way this parser works, I can just go over this really quick. I just think it's a cool little trick. So the parser here, right? It's the AST lives in dynamic memory, right? It's just a pointer to an AST. So is the lexer, which is a pointer to the lexer. And this is not the parser's copy of it. This is the lexer that already lexed the code. We just have a pointer to it. So anyway, there's these two pointers. What's cool is, since this is just a pointer to dynamic memory, when this function, I want to like parse ahead to see if we hit a C-style cast. So I want to parse ahead, but I'm just like scouting, right? I don't actually want to keep going forward. So I can make, by value, a copy of the whole parser. And the parser itself, right, like I said, it's just some pointers and some integers, right? It's super cheap. We can just make a copy of the actual parser by value. But now this copy has its own pointer into this AST, right? And into the lexer. So this whole function can run all the skipping and the grabbing of tokens and all that stuff on this temp parser. And then when we're done, we don't care. When we leave this function, we're right back where we were on the top level parser, which I think is a fun little trick. I think it's cool. Makes the life of a function like this way easier. So you can see we do everything on this copy. We can advance, we can go ahead, we can do all that stuff. Yeah, so because the parser is, there's no hard data on this parser struct. It's all pointers to other memory. So as long as I make copies of those pointers here, I can skip ahead and do all I want on the copy, and the original's still, you know, where it needs to be. So we are looking at cast specifier is a parent open. Oh, right. So we saw this. To see if it's a C-style cast, we look at the very next thing, and if it's a C-style cast, the next thing is going to be a known type. But in this case, it's a parent, so this should just fail. This was not a C-style cast, which obviously it's not. It shouldn't be. So, okay. So it wasn't one of those. We still didn't get anything, so let's parse an expression. We're looking at the parent. We're going to once again parse a leaf. The next thing is an identifier, which is value. So, I'm a little confused why we didn't see 3 parents here. I need that ability because it's how my error handling works. Yeah, so I learned a lot of this from Handmade Hero also. If you notice, I don't use classes. These are all just bare structs, so everything's public by default. And I also don't use any of the STL for stuff, so like vectors or strings or anything like that. So technically speaking, my code base, stuff like move semantics aren't really a thing because I don't really adhere to them, or do I even really think about them. I just handle it where I handle it. If I wanted to make a deep copy of this thing, I would go write a function that does it. No vectors, how do you example store a list of variables? I just use straight arrays. Whenever I have data I need, I just use arrays. So sometimes they're hard-coded like this if I know the result's going to be small. Other times they are... I use this... Where do I have an example of this? I use this kind of pattern. Any of types is a dynamic array, and paired with it is the number of valid things in it. And that's kind of it. I just use bare arrays for that stuff. Yeah. And so another thing is I don't do dynamic allocation. So like when my program starts up, I allocate one big chunk of memory all at once. And then once I have that whole chunk, I grab little bits as I go. My allocations are just grabbing the next bit of this memory that I grabbed at the start. So anytime I allocate a new array, it's not really an allocation. I'm just saying, hey, this next chunk of the memory I got is now this thing. Well, yeah, so they're not really duplicates. It's more that because I grab it all up front and I chunk it out as I go, I don't have to worry about like your initial question is like lists of variables and stuff. I don't have to worry about... I totally lost my train of thought, but basically I know the number of things ahead of time as much as possible, and I'm never having to call out to an allocator ever except on program startup. Yes, exactly, yeah, because under the assumption that most things get generated once, I can take stable pointers to them and know that unless I specifically mark it as cleared somewhere, which I don't really do, my way of programming doesn't really do that, I kind of know that the pointers are going to be valid, right? And another nice thing is, because I don't know if you've heard of memory arenas, but the thing I just described where you allocate it all up front and then chunk parts as you go, it's a memory arena is what it is. So I just have, it's literally just a struct that looks like this. Here's the base, which is that initial place I allocated. Here's the whole size that I allocated, and here's how much I've used of it so far. So I know where to allocate the next thing. And to push stuff, this is my allocation function right here, right? I find out where we should start. So it's the base plus how much we've used. I increase our used size by whatever I just pushed. And yeah, I return a chunk of memory in my thing. So what's nice is I have this temporary space too, this temporary arena, that for a game, for example, every frame, I just reset this used back to 0. I guess the only thing is you wouldn't you waste memory in the arena allocator dynamic allocating, so you have to discard existing values. So you're basically never discarding. You would build that into the place where you're using it. So for this parser, for example, I allocate it all up front. I just load whole files into the arena as I go, and I parse through them. And any new information I got by parsing, I just stick that onto the arena as well. So by the end, I have this whole arena of stuff that when the program's over, I can just wipe the whole thing. I'm done with it. Along the way, I don't really have to clear memory along the way because I know the task I'm doing. I'm parsing, or I'm loading files, parsing, generating, and then I'm just done, right? So I don't really have to clear things along the way in that case. And I know 100% that that's going to work because when my program started, if it failed to grab that chunk I asked for, the program just won't run any further than that, right? So yeah, hopefully that makes sense. I still don't quite understand, I think, exactly what you're asking in terms of the failure cases, but for anything that's more dynamic, for example, that you might want dynamic memory, you would just build that into the chunk of memory that you're taking out of the arena. So like at the end of the day, you have limited memory. So you have a variable star params or something like that you can call parse param, and then you realize you need to add another param to the params pointer. Okay, yes. So you're saying you have an array of a certain size, and then you suddenly realize you need to add more things to the array. In a vector, it would make a copy that's bigger, copy stuff over, and delete the old vector, right? I guess when I'm programming, I'm never in a situation where that has to happen, I guess. Like, at worst, it would be... Yeah, I guess I'm trying to think. I guess I just don't have many situations where I'm in that situation, so I don't know if I have a good answer. Since I switched to this arena style of programming, I find myself not in a lot of situations where I don't know how many things I'm working with ahead of time. And in situations where I do, I guess I would have to see an example or get to a point where I need to do that, and I would see what solution I would come up with there. So, so for parsing parameters, so once it comes to parsing, it's a little bit, it's a little less straightforward when it comes to parsing because actually my AST is actually a linked list, in which case it's not a flat array, right? So I'm parsing things as I go and I'm just sticking them onto the end of the list. So in that case, it's not a great example. But like, I guess for like an individual node, if it has, I have a limited number of children, right? A node just straight up can't have more than 128 kids. And that's just hard coded right now. That's a case where if you were using like a vector, it could grow, but I guess, yeah, the way I use arenas, I guess, is just such that I don't really leave any holes. So yeah, anywhere where I'm using an array, I think I am just, if it's a place where I don't know how many there will be, I just give it some like upper bound value and just go with that basically. Because you're right, if I'm sticking things into the arena and it ever at any point in the future have to grow it, I will inherently be making a hole in the arena, like in my allocated space, which I pretty much just never do. So if I was working with the type of data where that might happen, I would probably use a different data structure than just a flat array, maybe like a circular buffer to do the parsing, and then stick those parsed things in a separate place once I know better what I'm working with, I guess. So like, for example, the temp memory, I can be parsing things and sticking it in this temp space, and then once I'm done parsing, I now know how many things I have. At that point, I'll go allocate the array. I can think of that pattern, for example. Yeah, it's hard for me to talk about just because I haven't programmed that previous way in a really long time. I've been working with these arenas and stuff, so I think I just think through problems a little differently. So sorry if it's a little bit rambly and hard to understand me trying to answer your question. I just don't have a good example of the thing that we're talking about right now to kind of show you in this system. Okay, so this should also not be... Yep, should not be a cast. Parse the expression again. So, now we see value. We see... this. We see value, right? Cool, yeah. I learned a lot of the stuff straight up. If you haven't heard of it, Handmade Hero. It's been on hiatus for a while, but the dude started in 2014, and... Okay, yeah, cool. Yeah, part of this was... I probably should have clarified up front, me asking what your knowledge base was before talking about it. That would also have explained a lot for me. But yeah, Handmade Hero, it's a dude who made a complete game and engine from scratch, and he streamed the entire thing. Every line of code he streamed and talked through it. And his method of programming is just very old school and against the norm, a lot like how you see me program on this stream. And I kind of just really fell in love with it and how simple things are and how fast things are. And like, for example, every time you see me compile, right? Every time you see me compile, it compiles the metaprogram from scratch. It's not incremental. It does the whole thing, runs it, compiles the ultimate generated code from scratch every time, and runs that. It does all of that in debug mode, obviously, in like less than a second, right? I know who that guy is, but I actively avoid him because he associates with another guy. I wonder who you're talking about. I feel like I know who you're talking about. It's a... Yeah, it's a thing. Things are weird. I find his insights into programming and making software not be horrible to be, for me personally, on my programming journey about, 10 years ago at this point, was pretty paradigm shifting for me. So, yeah, anyway. What were we doing here? Okay, so we see value. Parse expression leaf. Okay, so we have a decal ref. So, because it was just value, it wasn't a C-style cast, our left-hand side of this expression is just value, which is good. So now, peek the next token. Our left-hand side was value. Okay, we have already screwed up. We think this is a bit shift left because this got inserted into the tree. So we are already hosed from the moment we get here. We already think that this is an operator that shouldn't be there. I think it's definitely true in a lot of contexts that the window over which you can like allocate, deallocate all in memory is larger than just the lifetime of the variable's use. So I definitely think there's value in thinking that way. Yeah, I definitely agree with the philosophy or the feeling that software is these days software is way more complicated than it needs to be in terms of how it's built, how you build it, the number of dependencies, and just the amount of wasted energy we spend making the CPU do things it really doesn't need to be doing. And I feel like you feel it all day, every day when you're using a computer. In a way that honestly like bums me out. So anytime I see people who like A, know what they're talking about, and B, kind of pushing back against that even in little ways that they can, I definitely gravitate toward that. And for what it's worth, I try to do my part there when I'm making this stuff. Even though, like, not a lot of people are looking at my stuff, but who knows, maybe they will in the future, so. I also think that a lot of code, you just want to make a list of things and not think that deeply. Yeah, definitely. There are definitely, like, I totally get why, like, Python, for example, is so popular. Stuff just kind of works. If you want to do even kind of relatively complicated things, it kind of just works in not much lines of code. I think you can get there, though. Like, by the time I get this metaprogramming stuff up and running fully, there's a lot that I can do and say in, like, very small lines of code. But obviously, it has taken me a long time to get to that point. So, definitely don't... no judgment on people who just want to make stuff and have it work, like, for sure. But, like, for example, like, when I have to use something like Visual Studio every day, and if I'm counting up the amount of time that I have wasted, A, waiting for it to just boot up, right? And B, having to wait an extra half a second for the watch window to update. Over years of using Visual Studio, that stuff adds up, you know? And a lot of it is just not, in my opinion, not super necessary. If people just paid a little more attention to writing things a little more sensibly, you know? But yeah, definitely don't. I definitely don't have any problem with people just getting stuff done, especially if they're new. Like hopping on a Unity, not knowing how game engines really work, and just making your game. Stuff like that, for example. People who just use Python to get stuff done, it's totally fine. I'm not. I just know for me personally, I want to grab every single part of it and know how it's working and make sure it's rock solid. I honestly don't have enough perspective to say why it's slow. Yeah. In a lot of cases, I don't either, but the more I do it and the more I make, so like, now that I know what goes into parsing code, I couldn't tell you why it takes so long to, for example, if I just wanted to like print out the AST in like Clang or something, it's obviously doing a lot more than mine is, but it is also noticeably slower than what I'm doing for the relative amount of more stuff it's doing. It doesn't seem like those numbers add up to me. Now that I see more how this stuff works, and I think it all just comes down to, at the end of the day, just the way the code is written. Like I said, I really just don't touch the STL at all. It bloats compile times. I think the data structures themselves are also just pretty slow compared to just kind of doing things yourself. And at least for me personally, I see a tangible benefit of it. But again, it also means certain things are just not very simple for me to do. So I get it, for sure. So why are we generating this friggin' nonsense in here? It's definitely this. It's this causing the problem. I feel like if I looked into why Visual Studio is being slow, I'd find that it's something to do with like the horrible OOP structure or something, like having bad synchronization code or something, rather than just how it allocates memory. So I think it's top down. Definitely the amount of crazy structure there is because of its OOP nightmare structure definitely probably has a huge part of it. It's probably just calling out to so many places to do even the simplest thing. But if they're also using like the STL, like std string, if they're using that all over the place, that is doing a bunch of allocations all the time. So like, I'm not saying they do this, but I feel like if they were to write whatever parser they use, they might be bringing in lines of the file and storing them in std strings, which is just A, slow, and B, really wasteful. I'm not saying they do that, but stuff of that caliber, you know? I remember this was a while ago at this point, like 10 years ago, but people found out that like Google Chrome, for example, when you were typing in the address bar, every single time you typed a new character, it was basically creating a new std string that was a copy of the old one with your new character in it. So the amount of allocations happening just by you typing out a URL was like insane. It was bananas, right? And I think a lot of it just comes from people who use stuff like the STL without thinking about what's actually happening. Again, to the end of just getting stuff done, which I understand. So it's not like a... Yeah. So it's complicated. I know not everyone has the time nor even the desire to dig into stuff. I personally do. I find it very satisfying and gratifying. And it also means that my stuff comes out really fast and kind of frictionless in a lot of cases. But, you know, it is what it is. Let me remove this entirely and just take a look at this output. So now if I look at this, oh, but it won't actually output because we're failing this now. Let me remove this not supported. Let's just not do that. Do we crash? Okay, cool. I just want to see what it does here. What? How is this still a problem? What? I took out what I thought was the problem code. Excuse you? Oh, it still didn't actually... Okay, right. It's not actually outputting the file. I guess I've never written large enough software to know if my code will be slow once it gets really big. Like if I go by current benchmarks, it would be reasonably fast if it scales linearly. Sure. Yeah. Which is fair, right? A lot of the stuff, for example, I don't know if I will ever write something that is doing everything that Visual Studio does, for example. Which may be part of the problem, honestly. Maybe it's doing too much, but I'm also working as one guy on a code base, so I'm very intimately familiar with all of it. If you're on a big team over decades, a lot of different people over a long period of time has touched that code. And that I don't know how, if you even can solve for. I don't even pretend to know that, so yeah. Okay. What if I don't append these? What happens? I'm just going to start taking things out until I see what happens. Why did that compile? Oh no, why did that compile? Value is less than... What even is that? How is that even compilable code? Excuse me? This should be the same as what's in that primary chunk file, but I just want to verify. How is this compiling? I'm confused. So with a C-style cast, do you not even need parens around this thing? And then what about, so this I'm definitely casting a 0 to S64. That's fine. Oh, this is like calling a constructor probably. Yeah, this is like constructor syntax. This is like, give me an S64 of 5. But in this case, it's of S64 0. That's what's happening there. How is that what it's generating, though? Right, that's why. Because we're here. We are now generating S64 and then this. So... Oh, wait a minute. Hold on. If I do this again... Let's go back to here. I was not getting this before. This greater than was not there, I don't think. Or maybe it was, but what I can see here now is this paren is matching the... It's matching the paren for this ternary... Okay, first of all, less than, any binary operator should have a space after it, straight up. That's just dumb. That's just gonna make this not work at all. So, binary operator, left-hand side, symbol, space, right-hand side. That much should fix that part. That's why we're getting the weird bit shift. And now we compile. This may have been way simpler than I even thought it was. This is dumb. Okay. Now this looks right. Now that I've separated those two things. Oh my god, this is so stupid. That's embarrassing. You know the other frustrating that's covered in combos about performance in languages? People will post the performance of their vectors, maps, etc., then act like that tells you how fast the language is. Oh, sure. Yeah. That's the thing, right? It's not that hard to show a single thing and be like, look how fast this is. That's how awesome this is. And then you try to use it in a production environment doing more things and it kind of breaks apart. Like, that's why I'm very excited. Right now, when I run the metaprogram and do all this stuff, it's pretty fast, right? Especially when I actually am going to be using this. This compiling part will end up taking a lot longer because you'll be doing this in release mode. But you won't be updating your metaprogram all the time. So you're only going to really be compiling it maybe like, honestly, really once, unless you're doing a bunch of metaprogramming up front, right? Then all it does is run it. It never recompiles it. So when it's in release mode, this thing is lightning fast, right? So I'm curious to see once this number gets a lot bigger, once I'm doing more things, and this is in release mode, I'm curious to see how the speed scales, because I just don't have enough code right now to know what that looks like. So part of me is a little worried that it's going to just like break down, but I'm also not that worried because I've never actually even profiled this yet. So I don't even know where the pain points are right now. So anyway, okay, so that just worked. So are we just good now? Did I just fix that? Are we just like done? Does this just work now? Oh my god, that's so embarrassing. Do all these work now? Dude. File. Function. Counter. Line number. Counter. That's so stupid. Oh my god. Okay. The last time I tried to do this, where I was trying to inject these, literal typecasts, I just hit a bunch of problems. And I gave up because I was tired. The literal only problem was that I didn't put a space after the binary operator. So it was creating these in places where it shouldn't. Or these Although, that should actually parse. That should parse fine. It's specifically this and this that don't parse. That's so stupid, dude. Okay, it's fine. We're there, though. This works now, which means I should also be able to just say, like, print... let me turn on the other ones that I turned off for this. Here. And here. And... oh, God. Why did it not... boom, 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 boom. Ah. That's another thing I don't like about forcoder. I don't know exactly why. If I select all this and comment with a shortcut, it puts new line or one line comments in front of all of it. But if I did it up here, it puts it in a block comment. So I thought all of this, I wish all of this down here was in a block comment, and it's not. So that's just, don't know why it does that. Don't know why it decides in some cases to do it one way and in other cases the other way. This is not ready yet. Support this next. This is also, I don't think this works yet either. Okay. We can't resolve values statically yet. 89. What? So parameters to struct templates must be literal. Oh! That's no longer just a literal being passed to this. Okay, I can do one of two things here. I can either special case this parameter, or okay, that's inject literal typecast. So, and actually, let's just not do this at all if it's already in a cast. I think when it comes to, what does this error say? We can't resolve values statically yet. Resolve values statically. If it not is literal type. Okay, we'll change this to if not resolves to literal. Right? We'll say this. So where is literal type? Is literal type? That won't be there. We'll put it in util. How about that? Get param type. Yeah. Okay. We'll have B32 resolves to literal. This will take a node. So, if is literal type node, then sure. If node type no, because down here we also have to also, why is this message outside of the where we use it? That's weird. Here's what we'll do. This will instead return a node And this will be literal node this. If not literal node, then we can check the literal node type here. So this thing's job is, if it's a literal type, we can just give the node back. If it's a cast, node type is AST expression cast, then return resolves to literal node children 1. So that'll just work its way down if it's a bunch of casts until we get to the very end, see if we hit a literal. Right? Cool, we crash. If not literal node, if literal node type does not equal, okay, let's just see what we got. Where are we? Got a program. Actually, let's do this. Print node nicely, literal node, and be verbose. I appreciate you sticking around in chat for so long and interacting so much. It's cool to talk about these things with someone who is even remotely interested. So, okay, we crashed before we even get there, which isn't great. Is it because if node children get num valid children node greater than 0? Didn't do that. Is that why? Are we just... No. Yep, me neither. And I actually took today off too. So, a lot of people that I work with took the whole week off. I just took today off. So, nice long weekend. Okay, so it wasn't that. So let's do this and this. We don't even get there. Okay, that's weird. The company you work for, the amount of days they give off is abysmal. That's unfortunate. I'm sorry to hear that. I'm very fortunate that they're pretty flexible where I work, and I know too many people who just don't have the flexibility, and it sucks. It should not be that way. That's where we're at, though. What is that? Oh, it's my search. That's rough. So wait, where are we failing? How are we failing this? If I put this back to matching call arg, and I put this to not matching call arg, did I break something else? What did I do? How did I do that? No, that's, never mind. I got excited for a sec. Okay, that runs. Hopefully once I got a year plus work. Yeah, I had that exact same thought when I started working, was if I can just put up with this job for like a year or two, I just need the experience, and then you could probably get hired. Suddenly, the scope of places that you can go, I keep bumping the mic, I'm sorry. The scope of the places you can go expands like exponentially, which is frustrating because you can't get that experience without working places, and you can't work places without experience. So it's tough out there. Okay. Resolves to literal. If is literal type, we return that. Let's just start here. Let's start here and say resolves to literal. Yeah, does that work? Yes. So now we'll say literal equals resolves to literal. This will go in here. If literal, if not literal, still works. So this we say if literal type still works. What did I do? How did I mess this up? It's here. So forget this, forget this, forget this. Can we do that and not crash? Yes. Can we do this and not crash? Yes. It's specifically calling to oh, duh. I'm getting the second child. I might be getting too tired. It's been a long night of this. Okay. So now we're not crashing, but we're also not passing this. So now let's print the node. I really want to get this part done though, because I'm in the middle of please have 50 plus experience in all of these languages. Comp sci, yeah. Yep. I heavily relate to that for sure. Okay, we're not even getting there yet. So because we must be hitting casts that don't. Wait a minute. Wait a minute. Because a cast... Am I stupid? I'm being dumb. Oh my god. If it's a cast, the only child of a cast is the thing that you're casting. The type is built into the node. Bro. Pay attention, please. Okay. Great. Those all go now. Now we're redefining things for some reason. Whoa. That's bad. No, it's fine. You can be negative. There's a lot to be negative about right now, so... venting is fine, especially in software. I feel like we're all in this together, so... Okay, I am generating something crazy right now, and I don't know why. Let's do this. Matching call arg. Okay, so why are we getting some crazy ass number here? When we're casting, it's because this is, where are we? This is turning into, oh, is it because I'm not using the literal, yeah, I'm not using the literal here. Oopsie. All of this should be the literal now. Yes, okay. I should use the value once I get the value from the thing. Okay, that still didn't... matching call param. If literal type is not an integer, we do this. Otherwise, we grab the value. Why is that one extra indirection causing us to freak out? Let's do this. Print node, nice. Let's print the AST of matching call arg and print the AST of the literal Ah, no. Ah, stop. Okay. Okay, let's see what's happening here. S64, 128, 128. So this all looks great to me. Where is this number coming from? We're losing this in translation somewhere. Append array dimension to variable. Wait a minute. These are array dimensions. Hold on, am I even looking at the right thing? I really jumped the gun on that. But no, that's the only place we call this. Hold on. Why does it think this is a decal ref all of a sudden? Hold on. I'm gonna copy this and go back. Hold the phone here. Let's go back here. We are in generate struct template, right? So, struct member of here, right? We're trying to generate this. And we were passed you know what? I don't want to cast. I don't want to cast in this case. Let's do this. If we have a parent, then if this, or let's do it this way. Switch on the parent type. Okay. We will continue. Okay, so if we're a cast, we don't do anything. If we are a meta template call, what do I call those? Oh, property. Shit. Okay, let's not do a switch statement. If it's that, continue. If literal wait. Parent is this. If parent is it just flags? Somehow I've gotten away with my STF with never storing the parent node. Oh, sure. So I specifically do that because when I'm doing metaprogramming, I want to be able to easily let you just replace a node, like pop a node out of a tree and replace it with another one. So by popping this node out, if I know who its parent is, I can replace it with one very easily because I can just hook it up to its parent. You know what I mean? I think that's literally the only reason I have these parents around. Like in this exact case, when I'm replacing nodes in the tree, it's helpful to know the parent. I can't think of another place where I actually use the parent like that. So, except maybe because I'm also doing code gen I think there's some places where I want to know that for context, maybe? I really don't remember. Is this just... node flags? Property... I could have looked this up by now. I'm being very lazy. Give it to me. Thank you. It replaces like the node with the meta injected code into the AST. Yeah, so for example, like in this case, what this is doing right now, do I have a cast in here? Right. Okay, so imagine for a sec that this was just a literal integer, right? It's a -1. What this current thing I'm writing right now is replacing all literal integers with a cast, right? And now that I think about it, instead of doing all this random skipping, I should only do this when it's a parameter. That's a much better idea. I'll do that. I'm glad I just did this looking at the tree. But anyway, if I want to replace this literal integer with a cast, I literally need to create a new node, right? So I need to create a new one, right? I need to make it a cast to an S64, right? So I make the node, but now I want to, I have this node and it's just kind of existing on its own. It's like floating out in space, right? I just created it. I want to replace this with this in the tree. And at this point, I got here not by looping and finding this pre. I looped over for all literals. So I am at this point in the tree, right? In my literal code, right? I'm looking for literals. So at this point in the tree, in the code, I'm at this level. So if I want to stick this in here, I have to, from here, be able to get to this. So I can make this the new child, right? And that's literally what this code is doing. When I say I have a helper function for it, you say replace node. Here's what you're replacing. Here's what you're replacing it with, right? So that function is taking this, sticking it there, and doing that. And then what I do is I call append child, which is then doing that, right? So it takes what I had before and gives me this back in the tree. Yeah, hopefully that makes sense. But yeah, so when I say the metaprogram is doing stuff to the tree, it's literally stuff like that. It's adding nodes, removing nodes, replacing nodes, and just manipulating the tree kind of by hand. So, and that's when I said the snippets are parsed. The snippets are parsed into, for example, in fact, here it is, right? Here's a snippet called assert message. Here's what the snippet code looks like, right? But then if I go and look for assert message, where do I do that at? Line? Here, right? So here's a case where somewhere, like right here, this line initially, when it was done parsing, if I go look at this, allocate virtual memory, right? It's in a function. If I go look at allocate virtual memory, that's not what I wanted. Here. I'm calling assert message right here, right? But if you notice in the tree, this is not a function call or even a snippet call. This is literally, it took that snippet up there, that whole body, this thing, right? It took this whole body, well, this part, starting here, took this whole body, replaced everywhere where it saw expression in here, it replaced it with whatever you passed, Wherever it saw a message in here, it replaced it with this. And then it parsed it. It literally parsed it as code, giving you a tree, right? It's giving you this tree. And then down here, once it did that, it took what used to be a snippet call here and called replace node and just stuck this whole thing, that whole tree it made by parsing, it stuck it in the tree, right? That's why I say snippets are more like macros. They're not function called because I'm literally replacing your code, but unlike macros, they're parsed into an AST first and then stuck into the tree. Hopefully, I keep saying that, but hopefully that makes sense. Okay, so what I want to do here, how about we do this? Let's flip this on its head. If it has a parent, and its parent is not a, hold on. I have to know if it's in a function call, is what I have to know. Is it a parameter to a function call? What's the best way to find that information? Is there an easy way to know that? Util? Get param type. It makes sense. I just never programmed in a language that allows you to do that, so I have no idea how useful it is. Okay, cool. Yeah. That was one of the things when I first started this project. I never understood why you would want to make an AST and do that when it came to metaprogramming. And now that I've done it, I see exactly why. It is immediately applicable that you can just mess with the tree and you can mess with the tree in place, which then affects the code gen. Okay, it's not in here. What am I missing? Yes, exactly. That's exactly what it was. And because my metaprogramming relies on knowing what the code is doing, and macros are not normal C code, right? It's text that gets like inserted. I could either go through the horrible process of trying to parse macros into real code, or just do what I'm doing now, treat it like actual code already, and yeah. I need to know. I need a good way to tell if something is part of, is a parameter to a function call. When it comes to Rust style macros, I've heard that that's how they enable metaprogramming, and I honestly just don't know that much about Rust, so I can't comment on it. I do hear that that their macros are pretty powerful, and that's how they enable metaprogramming. So, do I not have a way to do this? Okay, well. Okay. Is function call param node? Okay. I guess I just need to work my way up the tree until I hit a function call, or a decal, right? Ah, don't do that. If I'm going up, 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 and I hit, well, it could be a lot. You know what? I'll just go until I hit the source file. Well, in Rust, it's kind of like C++ macros, I guess, but like with syntax constraints, a bit like those Bacchus nar form rule requirements. I'm not even sure what, I don't know what that is. In terms of like literature and like what academia or whatever has to say, not academia, but just like whatever the literature says about a lot of the stuff, I'm actually not very well versed in. So, okay, so we're gonna say result is, actually here, we can just do this. Parent equals node parent, while parent turn false if we'll say if parent type equals AST source file break if parent type equals AST function call expression function call return true, otherwise parent equals parent sure. Okay, so don't do any of this. We just say if not literal. Wait, hold on. I do want some of that. Wait a minute. If parent and no, maybe I actually don't think I want to do this. I can just say if is function call param, if not function call param literal, continue, I think. Oops. Ooh, we went. We did the thing. I like that. Okay. I think we're good. There we go. We got our integer storages back. What was happening is this value that I stick on the end, so when you generate structs, if I ever got to learn math and more time, I like to learn math and maybe read part of computer programming and other books. I took a lot of that stuff in school. Like, I took a whole class on languages and, like, grammars and stuff like that for parsing and stuff. And, like, I don't remember any of that stuff. And it would definitely probably inform doing this kind of language stuff that I'm doing. But none of the stuff that I'm doing here is formalized at all. So, this is cool, though. Okay, so the way that we generate these structs is if I go look, when you define... So what's cool is I showed you can generate functions dynamically with the any syntax. You can also do that with structs. I've introduced, like, you can pass this type t. Again, similar to, like, templates. You can do this style of thing, too. You can have a struct take a parameter that's a type, and you can just use it like a type, right? So I can create an any struct, and when I go instantiate it, I tell it what type it is, and it'll just go generate this for me. And you can also do that with sizes, right? So that's what's really cool is, like, an any struct 2. I call this dynamic. It's not dynamic, right? It's a static array, but you can pass in the size when you create it. To be honest, I think a lot of the formal formal theory for languages, unless you're doing really complex stuff, is really useless. Yes. Yep. I totally agree. I also feel that way about, like you said, math in general. Like, I have a very intuitive understanding of linear algebra because I do a lot of graphics programming and stuff. I just have an intuitive understanding of what it means to transform in different spaces and, like, all this stuff. I took a linear algebra class and got, like, a C, right? I feel like that explains some of the difference between, like, the formal math stuff and like the usage, like the practical what you're trying to do with it, right? So yeah, I feel like that's a divide that happens all over the place. But yeah, so like you have these structs, right? And you can pass a type to it. And the way this happens is, so like here's integer storage. You pass a size to it. So when I go generate these, it's just an underscore to differentiate them. So like here you can see I've instantiated an any_struct2 that takes a short string and has an array size of 2. Here's another one I did that took a U32 and has an array size of 1. I just append it to the name like this. So what was breaking a second ago was this number was getting lost in translation. And giving us some crazy bogus value. So we're good now. So now when I say I want a integer storage of 128, there it is. And a 512 and a 1024. And then I am printing out all the values in them. And that's what we're getting here. Dude. Okay, I feel really good about tonight. It was a lot longer than I thought it would be, but I think proper math textbooks can be really good even if they're not practical. So dude, yeah, so that's another thing is, man, part of that, I was just not very diligent in school. In a way that now that I'm out of school, I have sitting right here, right next to me, is a giant linear algebra textbook, because I still plan on it at some point, is going through it and like learning the theory like properly. That's still on my backlog of things that I want to do. Like if I went back to school right now, I would totally go back to school just to take like a linear algebra course, a differential equations course, like stuff like that. I would totally do that right now at my age of like 33. And take it seriously this time and really like learn it well. I feel like a lot of people say this, but I did not take that part of school seriously enough when I was in it to know the opportunity I had. I solved like 8 chapters or something of a calculus book that was really challenging, and I learned so much about how to prove math statements just working through the problems. Yes, yeah. My favorite math class that I ever took, I mean, linear algebra was very proof-based, but like I said, just did not take that class seriously. I took discrete math as part of my computer science degree, 1 and 2, and that had a lot of proving in it, and that was some of my favorite stuff to do, honestly, was the proofs. And I think it's just because they were math, obviously, but they were less math and more like logic. Like you're proving things beyond a shadow of a doubt, like just A leads to B, so thus it has to be C, like stuff like that I find very satisfying. So I'm with you there. That's really cool. Yeah, it's stuff like that I want to do. I have so many things I want to do and just not enough time to do it. So right now this metaprogramming project is taking all of my free time I could do other things with. Okay, that's awesome though. So I think we're good. Get rid of this whole thing. And also having a better understanding of calculus. Yeah, yep. I get uncomfortable. Honestly, this is probably why it extends to like why I like doing this in software. I get uncomfortable working with things and knowing that I don't understand what's happening, right? That makes me really uncomfortable. Like, deeply. So, in some cases I just have to put up with it. Like I said, I have an intuitive understanding of linear algebra. I use it a lot in graphics programming. But I don't really... I couldn't take a test on it, you know? I just couldn't. And there is definitely something that bothers me about that deep in my soul that I want to remedy at some point, but, you know, I only have so much time, so it sucks, but it is what it is. Okay. I'm very happy with that. I didn't get done the stringification stuff because I wanted to do this first, but now that this is done, I have fully unlocked the functionality of these, so we are good. Some stuff is so fucking deep and complicated in math, though. You basically have to have your life consumed by math to understand it. I feel that, dude, as I've gotten older, so this is really funny. I've talked about this with other people a lot, but I'm sure you've heard of the Dunning-Kruger effect, where no, I probably don't need to re-explain it to you, but basically, like, you start learning something. It's basically the difference between your actual knowledge in a subject and your perceived knowledge in a subject. When you first start learning something, you supposedly get very confident and overestimate your knowledge. And then as you learn more, you slowly come back down to earth. That just straight up doesn't apply to me, and I don't think it ever has. In fact, I have a hard time learning new things because once I start learning about it, I am immediately overwhelmed by how much there is to know, and it's actually discouraging. Like, I don't know what the opposite of Dunning-Kruger is, but I feel like I have it. So, and it's actually like a stumbling block. It's something I have to like work on. So, let's push this up because I'm gonna be finished tonight. I don't know if you relate to that, but that's definitely something that has always plagued me. So, finally fixed the weird ambiguity stuff and made literals more robust. That's satisfying. Exactly 1920 insertions. That's fun. Okay. Fixed function call ambiguity by hard coding literals passed to functions by implicitly casting literals passed to functions. Okay, great. Okay, well, thank you so much for watching and for commenting and for interacting. That's fun. It makes streaming a lot more fun when there's someone to talk back and forth with. I mean, I see people occasionally, and a lot of times it's been me going over the metaprogramming stuff, but I think I know what you mean. It's like, I want to learn calculus, then you realize it covers like all these topics you may never have even encountered before, like L'Hopital's rule or all the weird approximations with Taylor series, and it just keeps going. Yep. And for me, it is discouraging. Like, I love learning, like, intrinsically, but it can be hard because I get discouraged pretty fast. It's rough. And at least with programming, I've done it my whole life, and I feel very confident in it. And it really is like a second language. I mean, it's programming languages, right? But I do feel like I am fluent in it. So a lot of that second guessing myself and frustration is with individual concepts. So like this metaprogramming stuff, I got discouraged a lot at the start when it was like learning how to parse stuff. But it was in the context of knowing how to program. So I already had an understanding, like a good foundational base. I keep bumping the mic. But yeah, like it would be like trying to learn calculus without having taken algebra, you know, and not having a solid foundation in algebra before you go into calculus. Thank you for saying that. And yeah, I try to keep that in mind, and I take it more these days as a blessing that I am seemingly invulnerable to Dunning-Kruger. That's the best way I can describe it to people when I talk about it, and I have started to think about it more as a blessing because that's another thing I'm deathly afraid of, is to be very confident about something and just be wrong. So maybe I swing too hard the other way and I'm just not that confident about a lot of things. But you know, we're all a work in progress. So, but yeah, like I said, thank you so much for hanging out, and I hope you come back for more streams. I'm probably going to be trying to stream a lot this weekend because I have so much time off. So I'm going to try and do it every night, depending on if I don't have other things come up. So yeah, thanks so much. You have a good night. Have a good weekend as well if I don't see you. And yeah, thanks so much for watching. I will catch you around later.